Assalamualaikum. My name is NUR ALIA NATASHA BINTI ROSLEE from DK024. I will presenting about galvanic cell. Question A. Draw and label the cell diagram. Show the movement of the electrons throughout the external circuit by using an arrow in the diagram. A galvanic cell diagram typically includes the representation of the two half cells and the external circuit. On the left side of the cell, the anode is represented. It involves the reactant undergoing oxidation releasing electrons into the external circuit. On the right side of the cell, the cathode is depicted. It involves the reactant undergoing reduction accepting electrons from the external circuit. Arrows indicating the direction of electron flow in the external circuit is often included. Electrons flow from the anode to the cathode.
Question B. Write the cell notation. Zinc in solid, vertical line, iron zinc 2 plus in aqueous, double line, iron copper 2 plus in aqueous, vertical line, copper in solid. Question C. The standard reduction potential values for inert zinc 2 plus or zinc equal to negative 0.76 volt and inert copper 2 plus or copper equal to positive 0.34 volt. Tug of war for electron between zinc and copper mentioned that zinc has a weaker pull for electron and copper ion, copper 2 plus has a stronger pull for electron. Based on both statements above, which electrode will be the anode and cathode? Give reasons for your answer. Zinc will be the anode and copper will be the cathode. The anode is where oxidation occurs and electrons are lost. Zinc has a lower standard reduction potential compared to copper, indicating that zinc is more likely to undergo oxidation. The zinc has a weaker pull for electrons, so zinc readily loses electrons at the anode. Copper, with its higher standard reduction potential, has a stronger tendency to gain electrons and undergo reduction, making it the cathode.
Question D. Write the half equation at the anode and cathode. At anode side is oxidation process. Zinc in solid will produce ion zinc 2 plus in aqueous and gain 2 electrons. In cathode side is reduction process. Ion copper 2 plus in aqueous will lose 2 electrons and will produce copper in solid. Question E. Explain the change of the mass of the anode and cathode. In a galvanic cell, the mass of the anode typically decreases as it undergoes oxidation, losing electrons and forming ions. Meanwhile, the mass of the cathode increases as reduction takes place, causing the deposition of ions onto the cathode. This redistribution of mass is a result of the flow of electrons through external circuit, maintaining the cell's electrical balance. Question F. Write the overall equation. Zinc in solid will react with ion copper 2 plus in aqueous, will produce ion zinc 2 plus in aqueous and copper in solid. Question G. State the functions of the salt bridge. Explain your answer in terms of the movement of the ions. The salt bridge in a galvanic cell serves to maintain charge neutrality by allowing the flow of ions between the half cells. In a galvanic cell, the salt bridge consists of an electrolyte solution typically containing ions that can migrate between the anode and cathode compartments. As the oxidation and reduction reactions occurs in the half cells, electrons flow through the external circuit, generating an electric current. The salt bridge plays a crucial role in maintaining electrical neutrality. During the redox reactions, cation move from the anode compartment to the cathode, while anions move in the opposite direction. Without a salt bridge, the accumulating charge in each compartment could hinder the flow of electrons and eventually stop the cell's operation. By allowing the movement of ions, the salt bridge prevents the build-up of excessive positive or negative charge in the half cells. This ensures a continuous flow of electrons, maintains a stable electrochemical environment, and allows the galvanic cell to function efficiently.